So we're going to continue talking about light's wave properties and how it demonstrates those wave properties. So just as a reminder, one of the first wave properties is propagation or speed, moving from one place to another. And that's related by taking the frequency of the wave times the wavelength is equal to the speed. And in this case, we use c, which is the speed of light, which is 3 times 10 to the 8th meters per second. And that's specifically the speed of light in a vacuum or in air. Now, electromagnetic waves or light waves are a transfer of energy, but they can transfer through a vacuum, unlike mechanical waves that need a medium. But they have all of the same structure. So they have crests and troughs, and they have wavelengths and amplitude and frequency. So when we look at this diagram here, the amplitude, when we talk about amplitude in terms of sound waves, it deals with how loud it is. In light waves, it determines the brightness of the wave, okay, or the amount of energy that contributes to that light. We also have wavelength and frequency, and those are related to what type of wave they are on the electromagnetic spectrum. So for sound, frequency means the note that you hear. For light, it's the color that you see. Or if it's not within our visible light spectrum, it could be UV, infrared, X-ray, anything on the electromagnetic spectrum. And so just keep in mind, if it ever talks about, how fast does a radio wave move, that you know the speed of it, that it's 3 times 10 to the 8th meters per second. So anything on this spectrum has the same velocity in vacuum or in air. Now, white light is actually a combination, as we saw in the video we watched about Isaac Newton, is a combination of all different colors of light in the electromagnetic spectrum. So it's somewhere between 400 and 700 nanometers, so all those colors mixed together. But if we were to spread them out into their components, you can see the different colors. 700, 6 to 700 is red. Lower down here, 400s are violet, and then everything in between. And we can actually split white light by using a prism. So when light travels through different mediums, it changes its speed and it bends a little bit, which we'll talk about in a later video, causing us to see the different colors of the rainbow. And that's how water droplets do this, or prisms do this. So if we go back to the first topic, we talked about wave characteristics. And so light has all of these properties that give it its wave properties instead of its particle properties. We're going to talk about the first 3 or 4, but know that light does interfere and diffract, but we won't learn specifically how to calculate these. We know that light reflects off of surfaces. That's why we can create images with mirrors, or you can see an image off of like a glass lake or any sort or any sort of reflective surface. Light can transmit through transparent substances, or like glass, acrylic, things like that. And as it does pass through that, it actually refracts, and we'll talk about what refraction is. It bends. And we also see can observe the Doppler effect from light. So if light is moving towards us, the wave gets smushed up and the wavelength gets smaller, and therefore it looks more on the blue end of things, whereas something that's emitting light, if it's moving away from us, it stretches it out and it looks more on the red side of things. So these are all wave properties that we can observe in light. And in the next few videos, I'm going to go specifically into the top 3 and give you some calculations on how to determine these different values.